The National Tillage Conference was held a few weeks ago and covered some excellent topics. We will revisit some of these excellent talks in the podcast as they provide great insight into the research being carried out in Teagasc Oak Park.
Nitrogen fertiliser use and yield are the main factors affecting carbon footprint. The carbon footprint of Irish grain is low by international standards. Given that we have some of the highest yields in the world, that's not surprising. What this will do, once we can apply it, is it's an endorsement of the sector's credentials to stakeholders in the value chain. So people buying grain, they can see that what's being produced on Irish farms is of low environmental impact.
You are listening to the latest episode of the Tillage Edge with me, Michael Hennessy. We would really appreciate it if you could listen, follow, and give us a review on Apple or Spotify or wherever you get your podcasts from. In this episode, John Spink, the head of Crops, Environment and Land Use in Teagasc, presented Irish tillage data using the new carbon calculator tool, which is programmed with specific Irish scientific data. John starts by providing some context to carbon calculations.
There are two carbon accounting methods, and people often get confused between them. They have what are called different system boundaries, so different things are included in them. The first one is the IPCC, or Intergovernmental Panel on Climate Change approach, and that's what's used for the national inventory, for calculating Ireland's emissions. And the second one is the Life Cycle Assessment, or LCA, and that's used to calculate the carbon footprint of a product. And it's per kilogram of grain, or per litre of milk, or kilo of meat, or whatever you want, but it's the carbon footprint of the product. For both of these, you need two things. You need what's called activity data, so that's things like the type of fertiliser you've used, the amount of fertiliser you've used, the cultivation methods that you've used. And in the case of the LCA, obviously you also need to know the yield of the crop, because that's what you're dividing the emissions per hectare by, however many tonnes you've produced. The second thing that you need then is an emissions factor, and there are various options for emissions factor. The basic level is a Tier 1 international default value, but you can produce more precise carbon footprints by either using Tier 2 or Tier 3 values, which are national figures, or then even more detailed where you need to model it. But I think the point is that as you produce a more precise emissions factor, you also need more activity data to go with it. Okay? And I'm not going to go through all the emissions factors and bore you with a heap of numbers, but these are just some of the ones, and these are particularly related to the nitrous oxide emissions, the on-farm nitrous oxide emissions. So for chemical N application, you've got CAN or NPK at the top. We have national figures for these. Work that we've done in Teagasc over the years has established how much of the nitrogen you apply is emitted. So in the case of CAN, it's 0.35% of the N. If we were to use the international default, that would be 1% of the N. So our emissions from CAN are about a third of what they would be. But also to point out then, there are emissions associated with the nitrogen in crop residues, or the emissions from the nitrogen in organic materials, and we don't have local national emissions factors for those, so we have to use in our calculations the Tier 1 factor. That's obviously something we're going to need to do more research on, because I suspect, and I think most people suspect, that those figures are significantly higher than they will be in reality in Ireland. Now, normally for an LCA, you're counting the emissions associated with producing something, and you'll all have heard of offsetting, or in this case, it's insetting because it's within the system. You don't normally include them in the LCA, but we've included in that we can add them into the calculations. So this is the amount of CO2 per hectare that's sequestered if you incorporate the straw. And this is assuming a straw yield of 4 tonnes a hectare. And you can see that if you're on light soils, you'll of that 4 tonnes, you'll sequester just under a tonne of CO2 into the soil, whereas if you're at the other end on a heavy clay soil, it'll be about twice that, at just over 2 tonnes. So we've incorporated that into the calculations. And what we've done is we've run through some of the data from Dermot's rotational experiment that Jack and Dermot mentioned earlier, and this is 5 years of data from 2016 to 2020. So I'm just going to go through some of that very briefly with you. So these are the calculated carbon footprints for each of the crops in the rotation. You've got the rotational crops there from left to right, and then the last 2 columns on the right-hand side compare winter wheat grown as part of the rotation or continuous winter wheat, and these for the plough-based cultivations. And you can see the continuous winter wheat has a slightly higher carbon footprint. That's because it has slightly higher nitrogen rates applied, and also because it's slightly lower yielding. And just looking at what contributes to that carbon footprint of the wheat, you can see on the right-hand side is the carbon that's embedded in the fertilizer we use, and that's accounting for nearly half of the total CO2 emissions for our crops. And then the lighter green slice is the emissions that are associated with applying the fertilizer, not the diesel for the tractor, but what comes off when you actually apply the nitrogen to the soil. And that's about another 24%. So about 3/4 of the emissions associated with wheat production are to do with nitrogen fertilizer. Fuel production and use, so that's obviously tractors, machinery for harvest, and about 14%. Crop residues there, it comes in the calculation at about 10%. As I said, we don't have local emissions factor, so I think that's possibly overestimated. Seed is about 3%, and crop protection is about 1%. That's the embedded carbon in crop protection products that you would apply. So in Dermot's experiment, he obviously has the cultivation methods, and this is the CO2 emissions for those crops either grown using shallow minimum tillage or ploughing, and you can see there's not really much difference between the two. That's because although you're using slightly less diesel in the minimum tillage compared to the plough, when you look across these 5 years that we looked at anyway, there's a tendency for the minimum tillage to be slightly lower yielding. So the two things offset each other, and overall the carbon footprint is very similar. So as I mentioned, we've built in the ability to account for carbon sequestered by the straw if you incorporated the straw. Now in Dermot's experiment, he didn't incorporate the straw, but we've done the calculations for what would happen had he incorporated the straw. So this is the kilograms of CO2 equivalent per tonne of grain produced, and that would be sequestered if you incorporated the straw from winter wheat, winter oilseed rape, winter oats and winter barley. And you can see there's a higher straw yield on the winter oats, so you're sequestering more carbon, and at the other end of the range there's winter oilseed rape. So we can now superimpose that over the emissions for those crops. So in brown is the gross emissions that I showed you earlier for 4 of the crops, and in green is the net. So that's what's left after you've accounted for the carbon sequestered in the straw. And you can see there for winter oats, if you can account for the carbon sequestered in the straw, you're getting very close to zero in terms of the emissions that are left after carbon sequestration. So just to conclude, nitrogen fertilizer use and yield are the main factors affecting carbon footprint. We need to do further research to refine some of the emission factors where we're currently having to use Tier 1 figures. The carbon footprint of Irish grain is low by international standards. Given that we have some of the highest yields in the world, that's not surprising. And we're hoping, or what this will do once we can apply it, is it'll be it's an endorsement of the sector's credentials to stakeholders in the value chain. So people buying grain, they can see that what's being produced on Irish farms is of low environmental impact.
So that's it for this episode, and my thanks to John for presenting at the conference. And we will revisit more talks from the conference throughout the year. The Tillage Winter Crop Walks continue this week. And tomorrow, Friday, February the 16th, a crop walk will take place in Jimmy Flynn's farm in Swords, County Dublin, and also in Kildalton College, Piltown, County Kilkenny. Both start at 11 a.m, and everybody is welcome. So finally, if you enjoyed the podcast, then recommend it to a friend or colleague. And as always, rate, review and follow on Apple or Spotify so you never miss an episode. And for more information, go to teagasc.ie. I'm Michael Hennessy. Thanks for listening, and I'll be back next week with more tillage news and advice.